All right, we're recording. Welcome everybody to this TWED for October 2024. We're very excited today to have Jamie McCusker give us what we think will be a very interesting and comprehensive introduction and demonstration of Whyis, the nano-scale knowledge graph management system. Just a reminder that we are recording these TWEDs for prosperity. They will be available via the Tetherless portal. And for people who search via YouTube. And we are making plans for a mid-November TWED. We're very excited at the possibilities of that. And if you're at all interested in presenting and leading TWEDs in the future, please contact me. So without further ado, Jamie, take it away and thank you.
Thank you. So the Whyis is a knowledge graph framework for, well, developing knowledge graphs. It is available through the Python package index, and I'll get through the process of showing that, but Whyis itself is if you go to whyis.readthedocs.io, you'll actually be able to find the documentation to be able to follow along with this. This is different from kind of the standard, the demo that we've used in the past, so it's not quite the same as the one that's in Getting Started, but it is, it kind of does some of the same things. So anyway, to get started, what we want to do is we want to, so using Python, we want to basically create a virtual environment. And so for those of you who aren't familiar with Python, basically you can kind of group your package installations up for ease of use, and to make sure that you're not kind of dumping a whole bunch of stuff into your kind of main system Python, and kind of then that leaks off across all other things. So we use venv as the way of building those. So if we just, so I've created a directory here called fact checks. I'll explain that in a second. But if we start by using Python, and then the version of the Python that you have, we're going to use 3.9, which is kind of the best. Had some problem with language models and the later ones, and kind of the earlier Pythons have some build challenges. So this is kind of a sweet spot at the moment. But -m, venv, env, and that will very quickly create a virtual environment called venv. We next need to activate it. And that gives you kind of a new Python, which is the same one that you had before. But from there, it's actually very simple to install Python itself, or to install Whyis itself. Pip install Whyis. Now, one thing to note is that you do want to have a Java development environment of 13 or later in order to run this. So you want to make sure that you have that available. This works best on Linux and Mac OS because there's a lot of Unix specific things in here, but what we're doing today should work in Windows as well. We've had success at doing that. Support for that's a little bit more complicated though. Second. Okay, so we've created a, we've installed all we need. We don't really need anything else for this particular for this particular knowledge graph. But if we wanted to install other things, we can just do the same thing, you know, pip install, you know, just it works the same as with other stuff. So let's talk really briefly about the knowledge graph that we're creating. I found this interesting data set based on the PolitiFact website. Someone's actually gone through and kind of collected up those all the fact check statements from PolitiFact into a JSON-based data file. Basically, we have these fields available. The verdict, which is, you know, one of these, ranging from true to liar, liar, pants on fire. It gives the name of the statement originator. There's the actual statement being made, that when it was made, where it was, where it came from, and then who did the fact checking, what the date was, and the link to the actual analysis.
So that's 9.84 megabytes. So is that this week?
No, actually, unfortunately, this was yeah, it's between 2008 and 2022. So it's not actually up to date. I think they left off in 2022 because it started to become a little bit more unmanageable.
Yeah.
One thing to note about PolitiFact is that what they consider to be fact check worthy are, number one, a person of note says something that someone's like, huh, I wonder if that's true, as opposed to something that is, you know, where they suspect it's going to be false, or or someone has claimed that this thing isn't true and therefore they're rebutting it. This is like a very proactive. I wonder if there's something going on. You know, there might be people who might doubt this or might have some question about its veracity, and so they will. There is a bias, though, towards things that aren't true because of that kind of initial level of doubt in there. But they do have, you know, they do have quite a few confirmations in here. If we want to look at the actual data, this is what it looks like. It's this is called a JSON-L or JSON line. Basically, it's a JSON object per line in the data file, which I've already downloaded. Now, one kind of important point of this is that this isn't a knowledge graph by itself. This is a tabular data set and doesn't really do anything on its own. So what we need to do is we need to convert this into RDF in order to be able to use that. And so what I've done, and I'm going to show you guys it first, is show this.
Names of folks.
Sorry?
I was looking at some of the names in that example. It's like old homes, what do we call it?
Old Home Day, yeah.
Old Home Day, that's what it is, yeah. Man,
Yeah,
could get us.
Blast from the past.
Yeah, blast from the past, that's right.
Okay, so what we use to convert this is a tool called Settler. And if you go to Settler, we actually have a tutorial up for, number one, how to install Settler, but also kind of how to build out a file and kind of what to do. This Settle file, we start off by, because JSON-L is a little bit different from conventional JSON, we need to kind of preload it in as a plain text object, and then we use this Python function to parse it line by line. Normally, we would use the built-in JSON parsing, but Here we use this approach because we just don't have, it's already broken out, and if we try to parse this as JSON, it's going to fail. We also have mappings for probabilities. I'm not sure we're going to do much with this today, but we have probabilities for the kind of level of veracity or confidence associated with each kind of statement, ranging from true, which is 0.99, to false, which is 0.01. Half true I give is 0.6 because there's some, it's not that, we actually say that 0.5 is a point of complete uncertainty. And so 0.6 is like, yeah, it's kind of true, or it might be true. And then pants on fire, we just load in the zeros in front of the one because it's just that that bad. These are all eyeballed. This is something that you can really kind of adjust for yourself. But and the other thing is that what we're doing with this, so you probably noticed that we called this fact checks instead of PolitiFact. This is kind of important because what we're doing is we're not necessarily building a PolitiFact knowledge graph. What we're doing is we're building out a fact-checking knowledge graph. And so there are lots of sources for fact-checking in the world, and a lot of their information has common representations. So what we're doing is we're trying to build on that commonality and kind of extend for specific things as needed for particular sources. Couple other things like, converting US dates to ISO dates, basically going from month, day, year to year, day, month, which is kind of necessary for being compatible with RDF. So then we have this data set, and we can link in these specific pieces of software by name, and they basically are assigned variables. So this entity from the graph called ratings, which is right here, is given an identifier of ratings in the template. And so when you access the ratings variable, that's what you get. If I change this to to foobar, then you have to access it as the foobar variable. It doesn't kind of what it's mentioned as in the external, in this RDF as a whole, isn't necessarily the same as what you will use in the graph itself, or in the template, which I'll get to in a second. This is how you actually use a particular piece of data, and what using will do is that it will iterate over the objects. It assumes that it's getting an iterable object with basically line numbers, and what you get is that object in a way that you can access it through the templating, and you get them one at a time. And this prov value template. So what this is basically a giant Jinja template. It's actually not giant compared to some, but this is this whole thing is a Jinja template that is that basically is outputting JSON LD. It's actually not quite Jinja because the Jinja parts are inside of any strings that are in the JSON here. So it gets parsed as JSON first, and then each string is parsed as, excuse me, as a Jinja template. That lets us have kind of JSON level flow control. So for instance, here we can say, we can put in a conditional so that this bit is only included if this evaluates to true. It allows us to do looping and all sorts of other things. And it kind of guarantees that when you output valid JSON, when you create a valid JSON LDT, a JSON LD template, it will produce valid JSON LD in the end. One other important part is the use of a context object here. This is the same as the JSON LD context. It's kind of tacked on to the JSON LD before it's parsed for inclusion in the graph. And what it's doing is it's basically evaluating this whole template. It's then parsing it as RDF into memory, and then it's adding it to an in-memory RDF graph. And then in the end, it spits it out as a file. And I'll show you how that works in a bit. A couple things to note here. We are using, so I'm actually, for instance, using the fact check analysis link as a source of identifiers, but kind of taking the prefix off and kind of stripping off the last slash that's on there. And I'll show you what that looks like when it's done. It's of type statement, that's from schema.org, but we also add in subclasses of statement, as you can see here, that are, let me make this a bit bigger, that are all classes. And basically it gives the statement source, which, as I showed you before, statement source is things like speech, or there's some that just say statement, and so I don't want it to kind of be, you know, a statement sounds kind of silly, so it's just going to be a statement here. But basically for each of the other ones, it goes through and shows you that. We record the actual statement itself, both as the RDFS label and as the schema.txt. And we link to the fact check analysis using DC terms related. We kind of pull in, and so this is, if you want typed data types in here, this is how you do that with by kind of using the @value@type approach for JSON LD. You can have kind of anonymous kind of pieces in the subtree. So I have this thing that's basically an attribute, and you know, it has a value based on the ratings that we had before. We link the author and again the fact check analysis link and when the fact check itself was created, and then we link the person who set it. And so you can generate URIs, valid URIs using the slugify function. You really do want to kind of experiment with it though to make sure that it's kind of creating the URIs that you want, because in some cases, you know, like I'm changing the separator here from dash to underscore and setting it to lowercase. This actually puts it very much in line with what you will often see in Wikidata, and so this is a way to kind of, it's kind of a pre-alignment in a way, but we're kind of using our own source of things. And at the very end, you can output it to a specific file. The other thing is that we can actually load these scripts into Whyis as RDF itself and have it be run by a agent, but we're not using agents today. I'm not going to go too much into that, but agents are a really cool way of kind of enhancing and adding to your knowledge without having to kind of build it out piece by piece or running things like this by hand. We can actually like schedule these things to be run and rerun, to react to new data that's been uploaded and so forth and so on. Okay, any questions to this so far? I know I blew through this really fast. It's not really meant to be a intro to Settler, but I just kind of wanted to whet everyone's appetite for using it and give a sense for what it's good for. While I answer questions, I'm going to run it. So you do that by running settler and then the path to the file. Okay, any questions real quick?
Okay, no. Okay.
None here so far.
Okay, great. Okay, so while that's cooking, I'm going to show you a couple of things that are kind of related to this. We have, yeah, that is transforming.
Wait.
No.
No, just keep going.
Okay, I keep hearing prompts in the background. So I'm going to show you how to run it as part of just kind of in a local thing, but we do support Docker. We actually have a Docker image that is kept up to date. And we also have kind of some scripts in place to allow you to just kind of deploy and install it into a server, which makes it quite a bit easier. This makes it a lot easier to manage. It's also something that if you want to actually turn this into a production web application, we can do that. And actually, one thing that I noted while this is while this is cooking, because I think it's not quite done. So one thing to note is that I realized that PolitiFact actually has these truthometer graphics, and there's actually a nice alignment between what they have in these file paths and the actual data that's been put in there. So in the data, we have these true, mostly true, half true, mostly false, false, and five, and those are actually aligned nicely with this. And so what I decided to do is to kind of link that in. So here I use FOF depiction and kind of map the row, the verdict for each row to one of the graphics for the truthometer. And I'll show you once this is done. Actually, we'll do this concurrently. It's almost done though. So whenever you do something with Whyis, you do have to source the activate script. That kind of adds all of the everything that's in the Python venv to the actual to your shell. Okay. Oh, good. We're done now. So the only thing that's left to do, I mean, we don't really have a knowledge graph yet. We just have some files on disk. Data. But if we look at PolitiFact turtle, we can see that, we've got the RDF that's ready to go now. And so this is kind of like the template expanded out and filled in using the details that we provided it. And we can see a RDFS label, related, author, the verdict, and so forth and so on. So what I'm going to do is I'm going to run Whyis, and what that's going to do is that's actually going to turn this directory into a KGApp, knowledge graph app. So if you look at it right now, there's a lot of stuff, sorry. If we have the venv that we created, we have the subtle script that we had been working on, and then we have the original data that I downloaded, and then the turtle files that are built. I'll go over this in a second, and then the images, or these images that I downloaded.
Could you do an ls minus al on that? Ls minus al on that data?
Why?
Because I want to see sizes and stuff.
Oh, data,
That should be fine. Yeah.
yeah. But actually, this might be more helpful. There, that's easier to read.
Yeah, that's fine.
Okay, so the next step, like I said, is we just run Whyis. Run. I'm using, so Whyis by itself runs in kind of a single-threaded developer mode, but we can, since what we're doing is we're running this with a kind of to actually use it to some degree, we want to run it in a multi-threaded mode. So I'm going to start that up that way instead of kind of in the easier to debug mode. This is, basically performant user mode. And of course, since this is the first time that we've loaded, we're running Whyis, Python needs to kind of build all the source files that it has included.
When it's running multi-threaded, how is it dividing things up?
Basically, it's a worker pool for all the HTTP requests that come in.
Oh, okay. That makes sense. So it kind of
So what we're seeing here, what we're seeing here is that it actually started up a basically there's so embedded config is basically when we're running in embedded mode, we have a bunch of different kind of sub processes that get started for various support aspects of it. So one of them is Jenna Fuseki. We run kind of we have kind of a randomly assigned port for Fuseki instance, and we can actually go to that to the endpoints for them, and it builds out the different yeah, down here it kind of builds out the different, no, I guess it's quiet, sorry. It's basically kind of initializing an empty Fuseki. And the other piece is that we use Redis. And what we use Redis for is we actually have Celery as kind of this embedded as well. And what Celery does is it lets us invoke the agents that I talked about before, which again, we're not going to use, but is definitely useful. So now when we go to localhost 5000, we see a web page, fact checks. Now, there's a few things that we have to do here. But what I'm going to do is I'm going to run you through the actual configuration before we actually start playing around with this. So now we've got a few more files, and those include, so if we look in the script, there's basically scripts for bootstrapping this knowledge graph on a new in a new location, so you can copy it to a new desktop for development, or you can copy it to a server. Server will actually just run the web server in development mode and then set up. Will basically prepare the system for a system install. So basically, it sets up services for Celery and Fuseki and Redis so that you can run it on kind of just a conventional server. The other thing that we're looking at now is that there's folders for static files. Basically, these are all empty, but you can access this when you're creating custom views, and you can create custom views in templates, and then you register those views in this vocab file. Now,
Isn't
we're not
Redis,
going to get into the specifics again of those too much today. This is kind of just going to be like the out-of-box experience with Whyis, but these are ways that you would go about kind of expanding and improving Whyis and customizing it to your needs. Sorry, go ahead.
well, just a general question. Redis is a key value store, isn't it?
Mm-hmm.
Yeah.
It is. It's used as basically as basically the task management tool, the same way that like Rabbit MQ is used by Celery as well, but it's much lighter weight, and it seems to do at the scales that we've used it at, seems to work just fine. But it's and actually I'll show you this soon. We also get this whyis.conf file, which allows us to customize a bunch of different things, including we can call as fact checks KG, and then change the description from something really generic to something a bit more specific, like web lies have truth and truths. We can change the, so the LOD prefix is the prefix that we are going to serve up locally as the, as kind of like the main body of entities that are in this graph. So I'm going to change this to fact checks for this, because usually you want something you have control over. I have control over the Whyis namespace at perl.org, but if you were putting this up at a, within your own domain, you would basically set the domain and then the path to wherever you're serving this as the LOD prefix. And what that allows you to do is when you are referencing entities in the graph, you can, Whyis will actually give you, will serve linked data based on whatever you have in here. So it will kind of take the local part that you put on, that you request from the server, and then it tacks this on at the beginning, and it looks that up as the source. So, and actually, let me show you how that works. What I'm going to do is I'm going to restart Whyis after I show you kind of the rest of the thing. We have the ability to map in other external linked data sources. So for instance, to be able to access and load data from doi.org, basically negotiating for a turtle. We've done it with ORCID and DVpedia and a bunch of other stuff that we don't have in the default, including like really specific databases like Uniprot, which is a protein database, or Obo Foundry, which is is an ontology. It's a collection and project of ontologies. So, and as I mentioned before, kind of the inference agents are available down here. We can also set them up for scheduled use. So anyway, that's kind of the bulk of that. So let's get Whyis started back up. And I will rearrange things once again.
That's pretty quick startup for a 23 megabyte, a graph based on 23 megabyte.
Well, we haven't loaded the graph yet.
Oh, okay.
That's one thing. So what I'm going to do is I'm going to start loading some data or some knowledge, I should say. Starting with, actually, let me just, yeah, no, I'll just, yeah, starting with this. So there are a couple of ways that you can load data into Whyis. The first one, which is probably the most efficient, especially for larger files, and I'll show you how to do that in a minute, is through the command line. And that's very simple, and you can access local data or remote data using this. So Whyis load -i, and then either the path or the URL, and then you can optionally give it the format of trig. But if it does have a useful file extension, it will be able to guess that. And so what this file is, this is quite a bit of kind of just, it's like OWL and RDFS and SCOS and PROV and a bunch of other stuff that we just generally find useful. So it's just a useful starting point for like all the meta ontologies and so forth that we might work with. So that's now we've loaded that up, and when we check here, actually first I'm going to register because we can't actually do anything through the web interface without registering.
Jamie, did it actually retrieve and load all of those ontologies in, or did it just?
Oh yeah, it did. Yeah, that loaded all of it. And so now we can go and say agent, and we can go visit DC terms agent, or actually, what is this from? Oh, that's interesting. And this is the RDFS class, and we can actually see instances of RDFS class here, which is kind of helpful actually, including SCOS concept. Anyway, so that's kind of just like when you start a new Whyis knowledge graph, it's a good idea to include it. It's not required because we try not to require a whole lot, because otherwise that will, if you have other ideas about what you want to do with your graph, we don't want to just start populating things that you're going to have to clear out, and that gets annoying. You can also load things from the, yeah, I should show, well, no, I will show you this next file. So I'm going to load it. I took the liberty of running. So when I created this subtle script, let me show that again. I used a number of classes and properties, especially from schema.org, that aren't really included in the base, but are really useful to have. And so what I did was I actually made a second very small ontology to include to include those things. And I call it FCO for fact check ontology. It's not. The thing is that there isn't really any, we don't have any new classes in here, but these are things that we referenced in the subtle script. It's actually, one cool thing is that it's actually possible to determine which ones these are through a Sparkle query after you've loaded the subtle script, so that you don't have to, you can just kind of go for it, figure out, get things to where you want, and then go back and actually figure out if what you have is sufficient. So from most of these pages, there's this menu on the right, on the left, I mean, that lets you, you can query data using Sparkle, and you can actually upload knowledge as well through RDF. And I don't know why it's showing me that. But so FCO, open. Here we do need to tell it that it's turtle, just for annoying reasons. And then the next thing is that actually, if we do, where did I put it? Right, so the other thing we can do with this is we can upload files. And so this is, right now we don't know anything about rulings. I just literally went to an empty URI, and now we can do things with it. But we can upload single files, collections, or data sets. I'm going to choose collection because it's a DC terms collection, and that's kind of what it's most about. And I'll take those images that I talked about earlier and upload them. And now we have each of these available. And if we, click the download, it will actually serve the image by default. But you can also view kind of metadata about those images. It'll show who uploaded it, the fact that it's part of the rulings collection. It has a creation date, image type, and so forth. And so we have some projects where that's actually a large portion of what we do, is we upload a number of images, and we do image analysis, and we're able to kind of pull out the parts and kind of build scene graphs of the entities depicted in those images, which has been a lot of fun. Let's see. So the next thing is that we're going to load the main body of the knowledge graph, which is the data that we transformed before. Load again -I, and then we data PolitiFact.turtle. And I'm not going to use the -f this time because I trust my software. And it is loading the data into memory, and then pushing it up to the graph. And that's going to take a little while because,
because that is 23 megabytes.
Yes, exactly. Okay, so it's parsed it. It's kind of created the, it's kind of prepared it for kind of the provenance that goes around it. So normally when you have, so we use something called nano-publications that lets you trace the provenance of all this data that you push through. And so it's actually created this this nanopub with this identifier, which lets us trace and track and even revert our edits, our changes to the graph. So now we have.
So is that treated sort of like a branch in a way?
Hmm?
That version identifier that you had there, That's
Yeah. Well, it's not it's just
not really a branch, but
not a branch. It's a transaction ID you can think of.
okay. That makes more sense. Okay.
So now we have people and statements in addition to all the other stuff that we had before. And we can do things like load these different statements in and
So these are what we're looking at, and if you go back a tab,
okay.
these are essentially layers of essentially different levels of Sparkle query that are presenting.
Right, exactly.
Then you clicked, what was that statement that you clicked into as an example? Yeah, I see. Okay.
So yeah, statement is, and actually I'm curious why I'm not getting the other types in here.
Well, you have multiple class there. That's kind of.
Yeah. Okay, here we go. Yeah, something didn't take quite right here. I'm going to load the that other file through SCL.turtle. Okay. I'm going to just grab one of these and figure out what is going on. Okay, here we go. Now we're starting to get these. So I was wondering where the graphics went, essentially.
Oh, okay. So you're saying with these statement instances, as part of the object, we should see the verdict graphics.
Exactly.
We're sort of saying, and we're saying,
Yeah.
we're seeing that there should be something there.
Yeah, I'm going to give this a quick. Oh no, here we go. I'm worried about the fact that the yeah, no, that's all fine. Why is it 500? What effect movements? Did I say something? Did I do it wrong? Um, it's fact checks. Oh, that's why.
Oh, it's a naming thing?
Yeah. Um, yeah, this is supposed to be fact check. Sorry about that.
But you're showing how easy it is to change.
Yeah, exactly. Of course, now that I did that, I do need to change the, I do need to re-upload the files. With effect rulings. One thing you'll note is that when we change the prefix, that changes kind of like what URIs we're looking at, right? And so now, I'm hoping, yeah, here we go. You'll notice that it doesn't really show anything in here anymore because this is in fact looking at a different URI than it was before.
Mm-hmm.
And so you get this prefix instead of with the S on it. So we're going to re-upload the files, graphics. Yeah. And then there are other things that are not quite working as expected, but I need to roll with it. Because we also don't have a, we're about to come up on time in terms of all this stuff. So I'm not going to worry about it. Here we go.
Oh, look at that. Sweet.
So here, let's look at something that CNN said. The other thing is that this will kind of do kind of an infinite scroll until it hits all of the instances in question. So from here, we get the fact that we are, oh, that's interesting. You know, we have the claim that CNN tweeted about brave children in Ukraine saying it to fight Russia. And some fire from some Instagram posts. Let's see how much veracity Instagram tends to have.
So this is sort of the instance view here.
Yeah, exactly.
Jamie, do you have sort of like a regular Sparkle, like a text, a form-based Sparkle endpoint?
Mm-hmm. Yeah.
There you go.
You can do everything. And this is also just a regular Sparkle endpoint too. So once you get this up and running, you can just query it and do your own thing against it.
The same URL for both the UI and
Yep, just take off .html. So it's just Sparkle like that.
That's convenient.
Yeah, and it's a write-only one. So
by default. That's
here we go. Oh my, that's
what's
Instagram
that doing?
is not doing well.
Oh, I see.
Yikes. Okay.
Shock.
Shocking, I know. I'm going to try and find someone who actually,
I think those should be GIFs.
okay, so I'll get Rudy Giuliani real quick. Well, we can talk while I'm doing this. I just want to show.
Jamie, I think, you know, in thinking through this, demonstration, it's pretty clear that probably the most critical aspect of the whole thing is the construction of the graph.
Exactly.
Settler thing.
Mhm.
I'm curious, sort of the kind of the investment in time and understanding that that it took.
Well, so there's some. Oh, here we go. I said some true things.
And I guess, to what extent did some kind of automation help you in terms of structuring that, if any?
Right. So there wasn't really any automation in terms of building this script. The output of the script is very heavily, it really helps in terms of automation. But essentially all I was doing was, I started off with, here, I'll, so these are all of, this is the Graph Explorer. It's a little tricky when you've got like really long labels. But anyway.
They're not color-coded or not.
Well, they are color-coded by the fact that these are statements and this is a person.
No, I meant by the
Oh, yeah.
Viscosity of them. That's what
Actually, because this is color-coded by type, if we say that, if we have the, for instance, here I have the verdict as basically an attribute. If I made the verdict another type. Here,
Oh, yeah. It would be. Yeah. Okay.
yeah. And actually, it should have showed up where each of these is its own. This is a statement. Or these are all. Oh, interesting.
Well, you should have said, Jamie, yes, they are color-coded. All of the light blue are BS. given the author.
Yeah. So anyway, actually, I think I know what I did wrong here, but we won't worry about it at the moment because we only have 5 minutes left. But I think that this conditional that I put in didn't do what I wanted it to. So I think it stripped out all the other sources. Anyway, like if we wanted to do a thing where there's we can add another class here saying that we can use the verdict instead of the source as a subclass for statement, and the fact that it's as opposed to true false or a truth versus a lie, or true statement false statement sort of thing. Anyway,
so as a person who occasionally gets asked to help people create graphs. I think that the real important observation for me is a real thorough understanding of settler is the critical thing.
It really helps a lot, yeah. Once you kind of get
regardless of whether the ultimate target is Whyis or just just creating a useful graph.
Exactly.
Settler is really what it's all about.
Yeah.
Whyis becomes a very effective knowledge graph management tool, but you've got to construct a graph first, and that's all about settler.
Right. And one thing that Whyis does do that settler can't do by itself is that you can, let's say you have multiple files that kind of all conform to the same format, you can reuse the same settle script over and over again inside of Whyis by you can basically make a templated settle script. And so that would basically let you, for instance, parse BibTeX files or parse files that have, maybe there's like, we could in principle actually crawl all of PolitiFact and scrape it out of the web page instead of using a data set. And Settler will do that kind of by itself. It'll do that for one page, but with a parameter having it templated or parameterized, it will basically do it for any page that you identify as a PolitiFact page. So it will just identify them by their RDF type.
So one last thing, Jamie, as we're coming to the end, can you talk a little bit about sort of, you can You could do an advertisement for like advanced features of Whyis, extensions to Whyis, that sort of thing.
Oh, yeah. So, as I mentioned, there's actually quite a bit that we're doing in terms of modularity and being able to add advanced features to Whyis. One of them actually is a brand new plugin that gives you the ability to basically post Fediverse compliant messages to the knowledge graph and have computational agents reply to them. And so you can actually have a conversation with a large language model through Whyis, have it be recorded in there and saved um, as a conversation. And because of the way it's put together, it's inherently multi-agent. You can have multiple agents replying to your messages, and you can have multiple people talking in a conversation together. And because there's points of reference within the knowledge graph, it's possible to kind of do graph rag against the graph, the context of the message itself, right? You can actually discuss any particular entity in here. So we can start gossiping about Rudy or about another thing, and we can either pull out from the knowledge graph kind of things that are known about it, or we can actually contribute knowledge. And then we have other things that we're working on that's a little further in the pipeline that lets you kind of extract knowledge from text using some of the same things, using some of the same technology, so large language models. Finally, this is all kind of tied in with essentially we've been really looking at how to integrate vector databases in with us. So we have the ability to kind of, if we have a vector database plugin that I could add to this, that would actually find, for instance, the similarity between all these different statements and let us kind of group them together. So we can pick a statement and say, give me like the top 10 closest statements in a semantic vector space using something like SBERT to kind of show this, show where these things fit together.
That's extremely interesting. The visualization plugins as well.
Yes, so we have, so I showed the graph exploration view very briefly. There's an RDF graph view, which I'm reluctant to use on a kind of a more complicated entity like this. Although here, you can listen to my computer fan again for a minute while I'm talking. Oh, no, it actually doesn't really show a whole lot here. But what
It's a false assertion, isn't it, right there?
Oh no, he exists, unfortunately. He's definitely a person.
Oh,
Quite the person. But the actually let's see here.
maybe it's just actually taking time to render.
Yeah, probably. You know, I'm gonna grab that one and we'll render the statement. We can look at the statement from RDF from the graph view. Finally, so also there's the ability to kind of create to look at the edit history of a particular entity. So all of the nano publications that are associated with it. Please work. Oh yeah, I still have some issues with layout, which we need to fix. But once this is back together, it will basically show boxes for each of the entities in the that are related to it and kind of tie everything together. But anyway,
That's very cool. So
the last piece is that we also have a ability to we can create visualizations here and actually show let's see here. So this will show kind of like all the this will let you write a query for in Sparkle, and then you can take a Vega specification, so or Vega Lite specification. Vega Lite is actually a really cool visualization tool that lets you create all sorts of really interesting graphics using a very simple specification approach. So it's grammar of graphics, but the grammar is actually a very simple JSON object. So it's all declarative. And so we have the ability to kind of connect those together between the Sparkle query, the Vega spec, and be able to build out kind of custom charts and visualizations for the knowledge graph.
Jamie, these names are causing me great angst.
Sorry, yeah. I realized that as I was done with this, I was like, this is either going to be very engaging or it's going to cause a lot of people a lot of stress.
Or both. I mean, it's engaging.
Yeah.
The politics depicted at this sample of time is very stressful.
Yeah.
Ow, wasn't. All right, so Jamie, thank you so much for this. This has been a great,
Thank you, Jake.
and for those of us who remember similar talks from over the past, like what, 5 years? Has this been going on?
Well, why has this been happening since 2017?
2017.
Yeah.
7 years.
Yeah. But the
quite an evolution. It's fantastic.
yeah, the latest one has been, so Whyis 2 was released in 2023, 2022, somewhere in there.
And Settler was kind of at a similar time, where Settler preceded development of Settler. How much
Yeah, that
more?
preceded it. That was more like 2015, I think, when Settler started to really come together.
Right. All right, so let's thank Jamie. No. Jamie, if you could stop the report, I probably could stop it.
I got it. Oh,
Yeah.
Okay.
I still see it recording.
Oh, sorry.